Today we're going to talk about solving systems of linear inequalities, and we're going to start with a problem that says tell whether the ordered pair is a solution of the given system, and this is for the system y is less than or equal to 3x plus 1 and y is less than 2x plus 2. Now, just like with systems of linear equations, the ordered pair has to be a solution of both in order for the ordered pair to be a solution of the entire system. So let's try this. Let's start by labeling these x as -1 and y as -3. Let's plug our values in and see. So we have -3 is less than or equal to 3 times -1 plus 1. So we have -3 is less than or equal to -3 plus 1, so -3 is less than or equal to -2, and that is indeed true, so it works for the first one. Let's try the second inequality. So we have -3 is less than 2 times -1 plus 2, so I have -3 is less than -2 plus 2, and so that gives us -3 is less than 0, and that is also true. So it works. So this ordered pair works for both inequalities, so this is a solution. We're going to say yes, it is a solution of the system. Now the next problem we're going to save for class time. That's going to be one of the first problems that you work on when you come in. And we're going to move down to this graph where it says graph each system of linear inequalities. Give two ordered pairs that are solutions and two that are not solutions. And so what we're going to do is graph these just like we normally graph a system of equations. We do want to make sure that these are in y equals mx plus b form or slope-intercept form, except of course we're going to have an inequality there instead of an equal sign. Now, y is less than or equal to 3. That is just simply a horizontal line through the point of 3 on the y-axis, and because it's a less than or equal sign, it is going to be solid. So let's go ahead and graph that solid line right in there. And it does say that y is less than or equal to 3, so we want to choose to shade the area below that. Now what I'm going to do is I'm just going to shade a tiny little bit, and you'll see why in a minute. We are going to shade for both of these inequalities, and I don't want to fill up my whole paper with scribbles, and what we're going to do is find out where the shaded areas overlap in just a moment here. Now in this other inequality we have y is greater than -x plus 5. If you want to write that in slope-intercept form, your m would be -1. So because this is like saying y is greater than -1x plus 5, the slope is -1 over 1, and the y-intercept is 5. So we want to go to 5, where the y-intercept is, and we want to go down 1, right 1, down 1, right 1, and we can just continue this. And we can also continue the pattern up in the other direction. Now, since this is a greater than sign, we are going to use a dashed line. Okay, so here is our dashed line. And we want to make sure we've got arrows on both ends. And we want to think about where that line is going to have values that are greater than -1x plus 5. And if it's greater than that line, it means it's going to be above the line. So we're going to just make a little bit of color up above that line. And we want to choose where those two shaded areas would overlap, where we would be below the first line that we graphed, the horizontal line, and above this slanted line with a negative slope. And it does look like this right in here would be the area where they overlap. So right in here. And of course, this does extend to the right beyond the graph, but that's all that we have for a picture. And so in this dark blue area is where we would find all of the solutions to satisfy both of those equations. Now, if we look back, the directions said give 2 ordered pairs that are solutions and 2 that are not. So we just need to pick a couple of ordered pairs that fall in within this area. For instance, if I pick this one, that looks to be the point 1, 2, 3, 4, 5, comma 2. 5, comma 2 would be a solution. Okay, let's pick another point that seems to fall in here. How about this point? It seems to be 1, 2, 3, 4, 5, 6, 7, I believe. Let's 1, 2, 3, 4, 5, 6, 7. Yep, 7, comma negative 1 it looks to be. So as long as it's in the shaded area, it's a solution. Just randomly pick any point that you can find in the shaded area, that's a solution. And something that would not be a solution, anything that is not in the shaded area. Okay, so that would be not shaded. So as an example, this point here is not shaded. So that's the point 1, comma 1. This point down here is not shaded. That would be the point 3, comma negative 2. You can see there are an infinite number of points that you can choose that would not be a solution. Okay, so now let's move on to, let's go to the next page. This next one I'm going to leave for us to work on in class. Let's go to this next page. Where it says graph each system of linear inequalities. And the nice thing is, for both of these equations, they're both in y equals mx plus b form. So the slope of our first line is 2 over 1, and the y-intercept is negative 4. So let's go ahead and graph. So we go up 2 over 1, up 2 over 1, up 2 over 1. And go in the other direction as well. It is a less than or equal to sign, so it is going to be a solid line. Put our arrows on the ends of the line. And it says less than or equal to, so we will shade below the line. Okay. Now with the other equation, y is greater than negative 2x plus 5. The slope is negative 2 over 1. The y-intercept is 5. So let's go up 5. And there's our first point. And then we need to go down to right 1, down to right 1, down to right 1, and so on. And we want to, oh, now first of all, we need to decide, is it going to be a dashed or a solid line? And since it is a greater than sign, we will use a dashed line. Okay. And since it's a greater than sign, we are going to shade above it. But we only want to shade where it would overlap with the other line, which would be in this area right here. And so this area where the shading overlaps with both problems, with both inequalities, is where you would find all of the solutions. Okay? And if you look at problems 2 and 3, we are going to do those in class when you come in. And also the word problem at the end, that's another one that we're going to work on. But I think you've got enough to get started. And if you do want to try a couple of those graphing problems, that's fine. If you want to go back and try the second graphing problem that's listed on this page, go ahead. However, just remember to get that first inequality into slope-intercept form. And I'll see you in class. Thank you.